lot of you guys have used virtualization software like VirtualVox, or I think like VMware Fusion is another one, where like you're basically virtualizing the entire operating system. However, that's really resource intensive because you're kind of virtualizing the entire operating system. But if you wanted to run applications without that kind of overhead, you could use containers, which is just basically a way of isolating processes instead of running them inside of a virtualized operating system. Okay. I have two displays going, so sometimes I'm trying to like go to the next page, but I'm on the wrong display and it's not working. Okay. So I think a good analogy is like when on Windows or Mac OS where you have multiple, you can like separate your desktop into multiple desktops where you can have Windows and like all these different virtual desktops, and it separates the windows for you. And that's kind of what things like Docker do, where it just isolates the processes into different containers. But kind of from like the host operating system's perspective, they're all just regular processes. But from the Windows, like the actual Windows themselves, they're kind of, from their perspective, they're isolated from the others. So I think that's kind of a good analogy. And if you look at the picture on the right side, which is kind of what Docker is, there's no virtualized operating system. Like they're all running inside of this container engine, which would be, I guess, Docker in this case. But on the left side, we have all these different guest OSs, and that's where a lot of the overhead would come into play. But you don't have that on the right side. It's just kind of just isolating the processes without having to run a whole separate operating system. Okay, so I hope all of you installed Docker already. If you haven't, you can either just use this link or Google Docker Desktop and download it from there. And hopefully, if you open up a command prompt, you can type this command Docker version. And then I go to here. You'll see that I have Docker, and you have to make sure that Docker Desktop is actually running, because if you have it installed and it's not running, you can't actually connect to I think it's called the Docker daemon. So you have to make sure that it's installed and running for this to work. Okay. So basically, images are like a read-only template that contains programs and libraries and basically like your application that you're going to deploy.
So,
and a container is like a runnable instance of that image.
Question for you, Ryan. In case they cannot get the Docker running, like if it says like Docker is not running, what should they do?
I think in your post you mentioned using, was it Microsoft Azure?
Well, but like, if you had downloaded Docker on your computer and it's just like the daemon is not running, is there a way to start it?
I think if like you can just search for the like Docker application, there's a GUI application, and once you launch that, then the daemon should start up automatically.
Yeah, it should start automatically, right? So it should be running if you already installed it.
Mine didn't start, but I had to install. I have some other stuff like enabled, and it might not be for other people, but I had to install the WSL Linux.
Oh, really?
Yeah, so see like this, like you might have to go into your Windows features and turn on Hyper-V.
I've never, sorry.
Sorry,
I was just going to say, I don't think I've tried this on Windows before.
Okay.
So, David is saying, yeah. How do you enable that, Richard?
So, type in Windows features, turn on or on Windows features. And see, I don't even have it enabled, but I don't know why. Then there's this there's a box, and in the middle there's one called Hyper-V. You might have to check that.
Mine is checked, but it's still saying the same thing.
Turn it off and try it then. I don't know.
You may need to restart or something after you doing this, right?
Oh, yeah.
Yeah, so I installed it, had to restart, booted back up, And then when I started up Docker, it wanted me to install WSL2's Linux kernel
Yeah,
to use Docker.
yeah.
That's what you had to do?
Yeah, and then I just went online and it had auto commands for you, and then you just restart it. But I didn't do
Mhm.
anything after that.
So is yours running?
Yeah.
The Hyper-V thing?
What happened?
Or is that not what we're talking about?
If he has on-
I'm talking about the kernel thing that I had.
Oh, gotcha.
And yours is running now?
Yeah,
Excellent.
I just didn't do the part.
I don't know how it's.
Yeah.
I just assumed it turned on Hyper-V automatically to use WSL2. This is usually what you have to turn on to use WSL2.
David, did you have to install WSL yet?
No, I haven't. But it's still not working.
You mean, did you install it already?
No, what is it called?
WSL is the Windows subsystem for Linux. So you may need to install that.
Here,
Or you can write it there.
it's step 4.
Oh. So this will give you.
So isn't Hyper-V something separate than the WSL?
Probably, but it sounds like in Windows
What?
you need a WSL for it, for running Docker, so they need to install it anyway, right?
Mm-hmm. Hyper-V is different than WSL2.
Right. Anyone
I
else?
think like in older versions of Docker before WSL, they used Hyper-V, but then once WSL was released and got better, they switched over.
Oh, really? So is either using Hyper-V or Linux?
Yeah, I think it's using one or the other, probably.
Interesting. All right, we need to help. I will help David if he gets stuck there, but let's see. Anyone else having trouble?
I'm good.
Fawn is good. Fawn get it to work.
Yeah.
If Fawn can get it to work, everyone should be able to get it to work.
You're
right?
not wrong. I don't know how I made it this far.
You're good, Fawn. You're good. You did it.
One more time, backwards, a lot easier.
You should be proud. Who's saying something?
What's that?
I said once more, Mac continues to prove itself to be a lot simpler. I haven't had any issues, and I did this earlier.
All right.
I think Linux wins though. I just open up a terminal and type sudo apt install. I got
You're not
it.
wrong.
All right. Let's listen more to Ryan about what's happening in this Docker thing.
Okay, so back to this slide. I think I mentioned images are basically like read-only templates for your application, and they include libraries, your source code, and like any configuration files that you would need. And then to actually run it, you create a container, which uses the image as a base and kind of turns that into a runnable instance. And if you remember from, I think like intermediate programming, or I guess like all programming since then, you can think of an image as like a class and a container as an instance of that class, where the image is just kind of like used as a base, and you can create multiple containers based off of that, where a container is like just, you know, an actual instance of that. And Docker Hub is a website, I think, made by Docker, or hosted by Docker, that contains a whole bunch of different Docker images for different software packages. And some examples here are like, there's some for Python, and there's some for Node.js, and some for Nginx or Apache, or just plain Linux distributions like Ubuntu. And you can also tag images with a colon after it. So in the examples here, there's Python 3.9.1, which specifies the version. And you can also do like dash, the Linux distribution you want to use, so Buster, I think that's for Debian. And there's Alpine, which is a really small Linux distribution. There's also, like, I think another one called Slim, which is like the slimmest version that the Python people were able to make. And if you don't specify a tag, Docker automatically uses the latest one, which I think for Python would be like 3.9 point something. But you usually don't have to specify tags because it would just usually use the latest one. You only have to do that if you want like a specific Linux distribution or version number besides the latest one. Okay, so to run your first container, if that Docker version command worked earlier, you can use this command where you're starting with Docker and then the run part kind of is used to create a container. And this IT is combining these two options, interactive and TTY, which lets you interact with the container. Like you'll be running in the command prompt and you can type in things and that container will be able to interpret that and execute what you're typing into it. And the RM option basically removes the container after it exits. And this is kind of just like going to be a demo container, so we don't want it to stay around forever. Because with Docker, it's really easy to end up with a whole bunch of containers. Like, if you're not careful, you can end up with like 50 containers if you just create new ones each time. And sometimes they can get really big and take up a lot of disk space. So you just use this RM option to remove the container after it exits. And then this is the name of the image. For this one, we're going to be using Ubuntu. And then another option after that is kind of the name of the command that you want that container to execute. Although you don't really need that, like you can run this perfectly fine without bash. And so I think bash is like the default entry point for the Ubuntu image, but just as an example, we can include that here. So I'm just going to copy that and go into my terminal and paste it. And I can just remove that bash part though, because I think it is the default already. So it wasn't able to find that image locally, so it's downloading it from Docker Hub. And all right, so it did download it, and here you see my prompt is actually different. Here was my regular one, and now I'm actually inside Ubuntu. So here's, I guess, the Ubuntu files. And I'm not sure, like, I think you can do like Ubuntu things, I guess. You can factor numbers, you can, wait, where's my, oh yeah, and just to explain the prompt a little bit, I guess for Ubuntu, it automatically logs you in as root. And whenever you create a new container, Docker kind of generates a random host name for you. In this case, it's just like a whole bunch of random numbers and letters. Where I think each container by default gets its own host name, but you can change that if you want it to be like more readable. And another Linux thing is like usually the prompt will have a $sign, but whenever you're logged in as root, I think the $sign gets replaced with that £sign.
So
The thing I want to point out is just like if you want to list your running processes, you can use the command ps-aux, and if you were to run like an actual virtual machine, you would see like, a whole bunch of other processes that are part of the operating system, but in this case, because it's Docker, there's only these two. And if you notice, one of them is actually the process that is using to list this. So there's usually only going to be this one process. And I think that's one of the good things about containers, because you don't actually have to run all those other processes. That like if you were to run a whole virtualized operating system, that would need it. So that's another good thing about this. Cat's gonna jumped on my keyboard and I can't type right now. Sorry about that. Okay.
Cat's keyboard now.
Yeah. So these are some other commands, I guess, if you want to play around. Oh yeah, so I guess you could do like something. For a second. You could do like yes and then like your name. Does anyone know what the command yes does?
just repeats it.
Yeah.
Over.
Like it's an infinite loop.
Yeah. It's a bad command.
copy can Yeah, so I think it's something you use for commands that like you're installing something and it asks for confirmation. You have to like type Y or yes a whole bunch of times. And you can use this command to like type Y or yes for you and install the whole thing for you and as like an argument. If it was like Y, it would do Y a whole bunch of times. And you can change the argument, and I think that was one of the purposes for the command. So like you can install things without having to be bothered to press Y every time, I think. And so to exit out of the container, you just use the command exit. So now you're back into your regular command prompt, like outside of Ubuntu. And if you do Docker container, this is like I think like the sub command you'd use to look at all the different containers you have. If you list them, because we use the rm argument, it should be gone. But if you left out the rm argument, it should be here. But I just did that because a lot of times you can kind of clutter up your computer with Docker containers sometimes. Okay. Oh, but if we go back to here, the image still should be saved here. So I have a few other images, but here's the Ubuntu one that I just downloaded, and you see it's pretty small. Like if you were to download like a Windows ISO file and ran virtualized Windows, it'd probably be like 5 gigabytes or something like that. But here, the entire operating system is just 72.9 megabytes, which is pretty small. Oh yeah, so we can also do Python, like as another example. You can try Node or a bunch of other things, but I'm just going to do this Python one, where Python is the name of the image and the tag is slim, which is just kind of like a slimmed down version of Linux. The distribution they're using, I'm not sure if it's like Ubuntu or something, but you can also specify the version, but without specifying the version, it automatically uses the latest one. So first it's going to download it. And now we have a Python prompt without actually having to install Python on our computer. I mean, I also have Python installed on my computer, but if I didn't, this would still work. So you could do Python things like I'm not sure what else you kind of want to do in Python, but you could do whatever you'd want in regular Python with this. And if you didn't want like a Python prompt, you could also use this to run like Python applications. And like say you wanted one application to use Python 2.7 and another 3.6, you can have different containers for different versions of Python. So in Python, I think the command to quit is quit, like the function. So you have to do it like that. And like I said, you can also do different versions of Python. So if you specify 2.7 in the tag, it would pull Python 2.7, and you can notice like the print thing, that's not a function anymore. I'm not sure what they call it in 2.7, but the print method is a little different. So you can't tell that's slightly different. So another important thing about Docker is Docker files, because like what we were doing right now is before we were just basically installing a plain Python image, using a plain Python image without any extra files. So if you wanted to use it to create an application, you'd want to create your own custom image that has your application code in it already, so you don't have to install it each time. And you specify all this kind of stuff inside of a Docker file. And a Docker file is just like a text file that contains a whole bunch of instructions telling Docker how to create your image. And I'm not sure if you go on GitHub and look at different repos, a lot of them, I'm not sure, like 50% or so, we usually have Docker files somewhere in there for using their app with Docker. So that's what these files do. They're used to kind of create custom images. So these are some example commands. You can copy files from your host computer to the image. using this command where src is like the path on your host computer,
Okay.
and dest is the path where you want to
So
copy it to.
before
and-
people seems to have done it, I didn't hear from Catch and David. David, are you still stuck?
I got it fixed. I had to enter the BIOS. The BIOS enable the
Oh yeah, you need to
that
enable
thing, the
the.
virtual thing.
Okay, that makes sense.
Yeah, because it was disabled.
Wow, that's
The WLS.
no the Hyper-V thing. You had to like go to the computer settings, like at the boot up, change it.
Sometimes, yeah, Intel or AMD force you to go into the BIOS to turn it on.
Yeah, I got it in there.
Yeah.
What's your
I think to try restarting the
It's called
Docker.
SBM. Yeah.
Yeah, SVM. Yeah, that's it. Secure virtual machine, I think.
I don't get why time is passing fast.
Oh, sorry, I was muted for a second. I didn't realize it.
Oh, okay.
He fell asleep too.
So I guess for this Docker file, it's a great one. I'm going to do it with Python. So here's the Python program that we are going to run, hello.py. So, so I made a folder on my computer called Docker, which is where I'm going to put all this stuff in. So I'm going to do, I think you could do like Notepad++ or something if you're on Windows, but
Right.
okay, so basically I created this file, hello.py. I just created this file that has this text, which is the Python code that we're going to be running, where it's asking for input and it's going to print it back out to us. So in that same folder, we're going to create a Docker file with this line, these lines. So the from command specifies the image we're going to use, Python, with that version. It's going to be sitting in an environment variable. So if I go back to here, to the actual code, you see that this is kind of like the Python code to retrieve an environment variable called goodbye. So in the Docker file, here we're going to specify that environment variable right here. And we're going to copy our program into the image, and then we're going to set the entry point, which basically tells Docker what command to execute when that container starts. So I'm just going to copy that. And create the Docker. So it's called Docker file, no extension. And then I'm going to paste that code in. So here are the two files we have in this directory. The hello.py is the Python file, and then that's the Docker file. So to actually build the image, we're going to use this command, and we're going to tag it with the name, because if you don't tag it, you might end up with a whole bunch of images with no names, and it's really hard to keep track of them. So I'm just going to copy this, paste it, and that will build our image. And it's basically looking for Docker files in the current directory. So the current directory is this folder, and there's a Docker file in here. So that's what it's going to use when it creates that image. Okay, so it built the image, and if we do Docker image ls for list, you hopefully should see that image that you built. And you can tag it with whatever you want. I just call it hello. That's kind of what the program's doing. So to actually run that, we're going to do kind of the same, where we're specifying IT. It kind of does it in interactive mode. And RM removes the container after it's done, and here's the name of the image. And in this case, hello is the name of a local image. And Docker will always scan, I guess, your local computer for images before going to Docker Hub. Because if you didn't have that image, I guess you would search for images on Docker Hub called hello. But because we just built one, it should use that one. So I'm going to run that. And just like kind of the code did, it's asking for your name, and I'm going to do I'll do Ryan. It said hello Ryan, and then it kind of did a closing statement. So this was the original file we did, and it kind of matches up with what it's doing here. And this audio's part comes from the environment variable specified in the Docker file. And I know this is kind of like a silly way of using environment variables, but a lot of times you'll use those to like specify like ways you want your program to run, instead of just like if this was a real program, you know, you want to use an environment variable, you could just do print, you know, audios right here. But if you had some complicated application that had all these settings that you wanted to specify as environment variables, you could just specify those in this Docker file, which is what they would usually be used for. And I think there was also, I can't remember the name of the command. I'll try to find it. I had a really nice tool for looking at Docker images. Can't remember what it was called.
When you install Docker on Windows, if you open it up, it actually will show you your containers and images like in a GUI.
Oh yeah. Well,
I don't know if you get that on the Linux install.
Do you know what?
another tool I was talking, I don't think this comes with Docker by itself, but it's kind of like a command line tool that you can use to inspect images and to look at like the actual file system and things like that are part of the image. And under the hood, images are kind of made up of multiple read-only layers that are stacked on top of each other and combined to form like this union file system. And these are the different layers I think that were used. These come from the, I think, Ubuntu base image. Or we used a Python base image, but that image itself used, I think, Ubuntu as base image, and it can kind of go back a few ways. Where these were from the, you know, the base image that we used, and I think this was what we added to it, where we copied the hello.py file.
Ryan, how did you get in here?
Just make sure you make that hello.py file in a certain folder somewhere, and then when you're in your command prompt, you want to change cd into that folder. Because you need that, you know, that file to be in your current working directory. So if like you do it in a folder on your desktop, you'd need to cd into your desktop. Like, and then like, you know, whatever folder you put it in. But I'm already in that folder. And you also need to make this Docker file, and it's just, you know, they're just plain text files. You don't need like a special editor to use it to create them. They're just plain text files that you can copy and paste. Where's my mouse? Oh. You just copy and paste this stuff in for the Docker file, and this stuff into the Python file. And it's just plain text. You could use like an IDE if you wanted to, but like, you know, Notepad or Notepad++ or whatever, you know, that would work.
Is there an extension to the Docker file, or do I just have it as a Docker file?
Yeah, just Docker file with no extension.
Okay, gotcha.
So if you look in this this program doesn't come with Docker, but you can use it to inspect images. So here is like the file system.
What's the name of this command, Ryan?
And what happened?
What is the name of this command you're using to inspect?
Oh, it's called dive, but it's an external program that doesn't come with Docker,
okay.
but it's called dive. Dive.
Okay, cool.
I can look, it's on GitHub.
No, that's fine. I was just wondering the name.
So if you look right here, this is kind of the file system that it's creating, and if you look right here, hello.py, that's the file we copied over. And it's putting it in the root directory because we didn't specify a different path to put it in. But if you had some large project, you'd probably put it in like a folder called /app/ you know, all your files there. But here's our file right here that we copied over to it. And you can see all the other Ubuntu. I'm assuming this is Ubuntu.
Yeah.
All their other files.
You build it based on, it's a Python image, right? Yeah, it looks like it's Ubuntu because there's like APT and stuff in there. Well, Everyone, thanks for staying, everyone. We're a bit above time, and I hope you get something out of this tutorial. You basically like built your own Docker image, and I hope you got the flavor of like being able to like pick and choose. Like you can like go to the Docker Hub. I have the link on the Reddit for the extra points. Like I told you to go to the Docker Hub and find the Docker image that works for your project. So if you want to do that, but in general, like even after your class, you should know that Docker is like a great technology for trying things, because you can download any of those images and run it on your computer without having to run like a complicated setup or anything. Like you can download, like run complicated programs like, I don't know, Apache web server or MySQL or Oracle or something like that. It's very easy to download an image and run it.
If you want, at the very end, there's also a few other slides that go a little into detail about how Docker works. And at the very end, there's also a video. And I think this is just a video of, I think I watched part of it where they're just kind of writing their own version of Docker using the Go programming language. And it just has a lot of cool things that I learned a lot from watching it. But yeah, there's also a few other details that I included on the last page, on the last slide.